Elementary events. Welcome, everyone. Today, we are going to begin a new topic in our probability unit, elementary events. To start, let's set the stage. In the study of probability, we are constantly dealing with what we call events. Now, don't let that term intimidate you. It sounds more complex than it actually is. Think of an event as a collection. It can be a single outcome, or it can be a group of one or more outcomes resulting from an experiment, like rolling a die or flipping a coin. However, before we dive into these larger, more complex groups, we need to understand the most basic building block of any probability experiment. That fundamental unit is what we call the elementary event. Over the next few slides, we will define exactly what makes an event elementary and look at some practical examples to see this in action. Understanding the elementary event. Now that we have introduced the concept of events as collections of outcomes, let's dive deeper into what makes an event elementary. By definition, an elementary event is an event that consists of only one single, solitary outcome of the experiment. There is nothing more to it than that. To really grasp this distinction, I want you to compare a general event with an elementary event. Let's use a standard six-sided die as our example. First, consider a general event such as rolling an even number. If you look at the possible results, this event is actually a collection of three different outcomes, 2, 4, and 6. In set notation, we would write this as the set containing 2, 4, and 6. Because it contains multiple possibilities, it is a compound event, not an elementary one. Now, contrast that with an elementary event such as rolling a 2. In this case, the event consists of only one single outcome, the number 2. In set notation, we simply write this as the set containing 2. In simpler terms, you can think of an elementary event as the smallest, most basic building block of any probability experiment. It is the simplest possible event that can occur, and it is unique because it cannot be broken down into any smaller components. The fundamental property of elementary events. Now that we have a clear definition of what an elementary event is, remember, it's just a single, indivisible outcome. Let's look at a very important mathematical property that connects these individual pieces to the bigger picture. On this slide, we are exploring the relationship between the probabilities of these individual elementary events and the total probability of the entire sample space. Here is the core property you need to memorize. The sum of the probabilities of all the elementary events in any given experiment is always equal to 1. Now you might be wondering, why is this true? It's actually quite logical. Think back to our definition of the sample space. The collection of all elementary events, when put together, covers every single possible outcome that can occur in our experiment. In probability, we call the entire sample space a sure event, and the probability of a sure event is always exactly 1. Therefore, if you add up the probabilities of every individual piece that makes up that space, the total must equal 1. To put this into mathematical terms, if we denote our various elementary events as E sub 1, E sub 2, all the way up to E sub n, then the formula is the probability of E sub 1 plus the probability of E sub 2 plus the probability of E sub n equals 1. We are going to see this principle in action in the next few slides using a coin toss and a die roll to prove that this rule holds up every single time. Illustrative examples. Now that we have established the theoretical definition of an elementary event, let's put this into practice with our first concrete example. Let's look at the classic scenario of tossing a fair coin. First, we need to perform step 1, which is to identify the sample space. When we flip a coin, there are only two possible outcomes we can observe. We either get heads, which will denote as H, or we get tails, which will denote as T. Therefore, our sample space, represented by the letter S, is the set containing H and T. Moving on to step 2, we need to identify the elementary events within this space. Remember from our previous slide that an elementary event must consist of exactly one single outcome. In this experiment, we have exactly two elementary events. The first event, which we'll call E sub 1, is simply getting ahead, or the set containing H, and the second event, E sub 2, is getting a tail, or the set containing T. Next, in step 3, we calculate the individual probabilities for these events. Because we are dealing with a fair coin, we assume that both outcomes are equally likely to occur. This means the probability of event E sub 1 is 1/2, and the probability of event E sub 2 is also 1/2. Finally, in step 4, we perform a verification step to ensure we are following the fundamental property we discussed in slide 3. We add the probability of E sub 1 to the probability of E sub 2. As you can see, 1/2 plus 1/2 equals 1. This confirms that the sum of all our elementary events equals 1, verifying our math is correct before we move on to a slightly more complex example involving a die. Illustrative examples continued. Now that we have seen how this works with a simple coin toss, let's increase the complexity slightly with our second example. Let's look at rolling a standard, 6-sided die. First, we need to follow step 1, which is to identify our sample space. When you roll a die, what are all the possible numbers that could land face up? That's right, it could be 1, 2, 3, 4, 5, or 6. So we write our sample space, denoted by a capital S, as a set containing the numbers 1, 2, 3, 4, 5, and 6. Next, in step 2, we identify the elementary events. Remember from our previous slides that an elementary event is just a single outcome. In this experiment, we have 6 distinct elementary events. We can label them as E sub 1, which is the set containing 1, E sub 2, which is the set containing 2, and so on all the way up to E sub 6, which is the set containing 6. Each of these is its own individual, unbreakable building block. Moving to step 3, let's calculate the individual probabilities. Assuming we are using a fair die, every single side has an equal chance of appearing. Therefore, the probability of E sub 1 is 1/6, the probability of E sub 2 is 1/6, and this continues for all 6 events, up to E sub 6, which is also 1/6. Finally, in step 4, we perform the verification step to see if the fundamental property we discussed earlier holds true. We add up the probabilities of all our elementary events, 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. As you can see, 6/6 simplifies perfectly to 1. This confirms that our sum of all elementary events equals 1, just as the theory predicts. Now, as we move to the next slide, I want you to pay close attention, because I'll point out some common pitfalls where students often trip up when applying these steps. Common mistakes to avoid. First, be careful not to confuse a general event with an elementary event. As we discussed in the earlier slides, an event can be a collection of several different outcomes. If you describe an event that contains more than one outcome, for instance, if you say rolling an odd number on a die, which includes the outcomes 1, 3, and 5, that is actually called a compound event. It is not an elementary event because it can still be broken down further. An elementary event must be the simplest possible unit, consisting of exactly one single outcome. Second, watch out for errors in summation. A common mistake is believing that the sum of the probabilities of any random group of events will always equal 1. This is not correct. As we saw in our examples with the coin toss and the 6-sided die, the sum only equals 1 if you're adding up the probabilities of every single possible elementary event in the entire sample space. If you only pick a few random events and add them together, you will likely get a value much less than 1. Remember, the total probability of 1 only applies to the complete set of all possible outcomes. Now, before we wrap up today's lesson, I want to pause and highlight 2 common pitfalls that I often see students encounter when studying probability. It is very important to keep these in mind to ensure your foundations are solid. Key takeaways. First, let's revisit the definition. Remember, an elementary event is simply an event that contains exactly one single outcome. If there is more than one outcome involved, it is no longer elementary. Second, think about the concept of simplicity. You can view an elementary event as the most basic, fundamental building block of any probability experiment. It is the smallest unit possible. It cannot be broken down any further. Third, we must remember the sum rule, which is a critical property we discussed earlier. The sum of the probabilities of every single elementary event within a given experiment will always, without exception, equal exactly 1. Finally, to put this into a mathematical notation that you can use in your calculations, we express this as the summation of the probability of all elementary events equals 1. All right, we have reached the end of our lesson, so let's take a moment to recap the key takeaways from today's session on elementary events to ensure everything is clear. As long as you keep these points in mind, especially the distinction between a general event and an elementary one, you will have a very strong foundation for our next topic. Great job today!